Hi guys, today we're going to talk about finding the greatest common factor, and we're going to do this through using prime factorization. And the I can statement we're working on is I can find the greatest common factor of two numbers less than or equal to 100. So if I want to find the greatest common factor of 24 and 30, I first need to find the prime factorization of 24 and 30. And I can do that very simply. And there's multiple ways. I'm going to choose to do 4 and 6. I notice that 4 is composite and can be broken down into 2 times 2. And 6 is composite and that can be broken down into 2 times 3. And I'm circling these 2's and 3's because they're prime. So if I wanted to write the prime factorization for 24, I would write 2 times 2 times 2 times 3. Now we had talked earlier about writing the prime factorization using exponents, and I had said that I didn't always like to do that, especially when I'm finding the greatest common factor, and here's why. We'll see this in this problem. Now we need to find the prime factorization of 30, and 30 can be broken down into 5 times 6. 5 is prime, so I'm going to circle it. 6 can be broken down into 2 times 3. And 2 and 3, as we know, are prime, so I'm going to circle those too. Now I need to write the prime factorization of 30, but I'm going to write this a little differently. I'm going to write it so that the factors that are common to both 24 and 30 are right underneath each other. So I have a 2, a 3, and I'm putting this 5 over here just because it doesn't have a partner. I don't have to do that. I'm just choosing to do that so that I can see what 24 and 30 have in common. So, step 1 for finding the GCF is prime factorization. Step 2 is to line up your prime factorizations and circle the factors they have in common. So, step 1, do your factor tree and find the prime factorization. Step 2, circle the common factors. Step 3 is going to be multiply the common factors. So they have a 2 in common and they have a 3 in common. And when I multiply that, I get 6. 6 is my GCF. Now notice, I did not multiply 2 times 2 times 3 times 3. I only need to multiply to show that they have 1, 2 in common, and these numbers have 1, 3 in common. They don't have more than 1, 2 or 1, 3 in common. Let's look at another example. Let's use prime factorization to help us find the GCF of 40 and 60. Well, step 1 is to do your factor trees and write out your prime factorizations. So, 40, I'm going to break that down into 5 times 8. 5 is prime, so I'm going to circle it. 8 is 2 times 4. 2 is prime, so I'll circle that. 4 is composite, so it can be broken down into 2 times 2. I have nothing else to break down. I've got all prime numbers, so I can write out my prime factorization here. 40 is 2 times 2 times 2 times 5. I'm going to do the same thing with 60. 60 can be broken down into 6 times 10. 6 is composite, so I can break that down into 2 times 3. 2 and 3 are prime, so I'm going to circle those. 10 is composite, so that can be broken down into 2 times 5, and those are both prime. So I'll circle those as well. And when I write out my prime factorization of 60, I got 2 times 2 times 5 times 3. Notice once again, I chose to write the common factors underneath each other so that I can find them more easily. Step 2 is to find the common factors and circle them. So 40 and 60 have 2 2's and a 5 in common. So now, step 3, to find my GCF, I multiply the factors they have in common. 2 times 2 is 4, and 4 times 5 is 20. So my GCF equals 20. Let's look at another example, just to make sure we've got this down pat. Step 1, I need to do my factor trees and find the prime factorization for each number. 30, while there are many ways to break down 30, I'm going to do 5 times 6. 5 is prime, so I'll circle it. 6 can be broken down into 2 times 3. 2 and 3 are both prime, so I'm going to circle those and write out my prime factorization. Now I'm going to do the same thing with 45. 45 can be broken down into 5, which is prime, times 9. And 9 can be broken down into 3 times 3. So when I write out my prime factorization, I have 3 times 5 times 3, and that's my prime factorization for 45. So, step 2 is to find and circle the common factors on my 2 lists of prime factorization. Step 3 is to multiply the numbers I circled. And when I do that, I find that the GCF equals 15. It might be a good idea right now in your summary portion of your WSQ to write down the steps for using prime factorization to find the greatest common factor. Step 1 is to do your factor trees and write out the prime factorization for each number. Step 2 is to circle the prime factors that both numbers have in common. And step 3 is to multiply the factors that you circled to find the greatest common factor. Now it's your turn. Use the prime factorization to find the greatest common factor of the following numbers. Put this in the work section of your WSQ. You can go back and watch any portion or all of this video as many times as you need to. Now pause the video and complete numbers 1 through 5 in your notes. Find the GCF using prime factorization.